Okay, it looks like we're ready to get rolling. Dan, are you still on as far as mic so I can talk to you?
I am.
Okay, perfect. Everything looks good, so I'm going to kick it off. Welcome to SLUGME. We're coming to you from Lincoln, Nebraska. SolidWorks User Group of Nebraska, SWOG 1.
Good morning, everybody. I am Gianpaolo Bassi, CEO of SolidWorks, and I am on my way to the office. Actually, Karen is driving me. Karen, say hi. Because as usual today I'm taking a flight, traveling internationally, and this is the reason why I cannot be part of this very special user group meeting, which I enjoy a lot. By the way, just last week I was in Japan with a reunion of all the representatives of the user groups in Japan. So SolidWorks is literally everywhere. So it is amazing to me that 60 SolidWorks user groups from around the world are participating in this annual event. And I would like to especially thank Todd Blackshear for putting it all together. I also want to welcome the members of 3 of the Boston area SolidWorks user groups that are coming to the Walton campus. I hope you enjoy the meeting, the night very much, the day very much, and I will, again, I wish I could be there with you. Very soon, starting momentarily, I know that more than 1,500 SolidWorks users around the world will enjoy special tips and tricks from the user group from Lincoln, Nebraska. I think it's a lot of fun. So again, Todd, thank you very much. Thank you for everybody. Thank you everybody for participating. And please tweet that SolidWorks is everywhere. Enjoy and take care.
When you tweet about this, tweet hashtag SolidWorks is everywhere. And we want you to tweet hashtag SLUGME just to let everybody know that you were here. We got a lot to cover tonight. I'm getting a good start, so I'm still going to cruise through it fairly quickly. These categories are highway to the danger zone, or shortcut zone. Sorry, Lana. Totally tubular. That's exactly what I weld meant. We'll look at a couple odds and ends. I never met a data I didn't like. And we'll finish by drawing me a bath. Okay, I'm just gonna jump into these. We only have an hour, so I'm gonna Ken Jennings this board, and I'm just gonna start at one side and work my way through. So first one under highway to the danger zone. A little bit of background about me. I started with AutoCAD. I got really good at keyboard shortcuts, and my keyboard shows it. So I'm gonna share a couple of my favorites. A is for almost anything. And this one goes out to my group, SWOG 1. All right, let's jump right in. All right, very simple sketching. Everybody should know this. About it, so I'm like, well, wait a minute, let's make sure that people know. A key is an arc when you're sketching. Everybody should know that, but there's some that don't. The A key is pretty versatile. That's not all it does. If you have selections that have multiple choices, the A key will toggle. If you look at the feature manager, the A key will toggle through your options. So if you have a slot, you can toggle through all these. The other thing that I really like, because I like to focus on the pointer, is that the pointer icon updates to show which one you're looking at. So A is a command toggle. Next one's going out, swords for 200, Alex, that's S words. This one's going out to SolidFacts. They are actually the 3rd SolidWorks user group to hit the 20-year mark. They just did that not too long ago. Big ups to Duncan Gillis and all the guys down under. Everybody should know about the S key pop-up. This is probably one of the best tools in my opinion. Knock this out. I add my extrude and my cut to the S key because that's usually how I exit a sketch. Little bit of side trivia for you here. How do you turn an extrude into a cut? Grab it, watch the feature manager, turns into a cut, it's an extrude, it's a cut, it's an extrude. Now the thing most people don't pay attention to with the S key, you hit the S key, you get the pop-up, but it also activates the command search. So you type in a command, it brings up that command. If you click right here, it'll take you right to the command. If you click on the I, it will show you how to get to the command. And this was something that I just found out last week, and I think he's there in Waltham. Thank you, Kevin Burney. You can drag this over to your, no, Kevin told me something else. This was a Jim Wilkinson trick. You can drag this over to your toolbar and add it. If you want to know where it's at, the arrow moves over, does the fly out, goes to the command. When you just click your mouse, there it is. I'm going to keep moving fairly quick here. Delightful. This one's going out to Kendra and the Panama City Beach group. Kendra's very dedicated. Today's her son's birthday, and she's at a SolidWorks user group meeting. I'm a big fan of Kendra, and if she will let me, I'm going to send her one of these that I won at a meeting for her son, whose name starts with D. All right, what does D do? Well, if you look up in the top left corner is breadcrumbs. Not your Hansel and Gretel breadcrumbs. These are powerful tools. When you hit D, it brings them right to your pointer. So your part, your body, your feature, you can edit your sketch. Everything you need is right there at your cursor. It also brings confirmation corner to your cursor. So if you think about it this way, it brings the top left of the screen and the top right of your screen to your cursor. It's a very slick tool for a part, but it really takes on a new level when you open an assembly, because when you hit the D key in an assembly, it brings up the parts, but it also brings up the mates. So say you want to lock rotation on that, it's just a right click on the mate. You can make your change right there. Really quick shortcut. A lot of these came from when I'd be showing something else and people would always get hung up on the little things and say, hey, back up, how did you do that? Well, it was just something that I assumed everybody knew, so. F+ is still failing. F also stands for frying, and what do we like to fry at SolidWorks? Bacon. This one goes out to James Adkins' group in North Carolina. Now, James might think that he's getting a little bit ripped off here because the big thing with the F key is it zooms to full screen, which is cool, but that's not all it does. And this is kind of the bridge in this. It's like a bridge in a song. It'll take us to the next one. Shift of control. Just really quick, Dan, do I have serious lag?
No, you're pretty good here.
Okay, perfect.
Yeah.
I just thought there was a little bit of delay. Shift of control. There's been a shift of control in Central Texas, and we have a new user group leader, Steve Calvert. He has taken over the reins of the Central Texas user group, and tonight is his first meeting. Congrats, Steve. Welcome to the family. Now, Shift, Control, Alt, Tab. All of these are modifier keys is what I call them. So the F key, poor James thought he was getting ripped off, but I use Alt F all the time. It's a standard Windows shortcut to bring up your file. Most of your standard Windows shortcuts work, you know, Control Z, undo, Control X, cut. And if you hold down Control and drag apart, most people should know this, but I still find people that don't, copies the part. Right click to rotate it. Alt key enables your smart mates. Drop that in there. Alt key on this, drop that in there. I've copied a part and fully mated it with a couple of clicks and a couple of modifiers. One of my favorites that I forgot about until I went to a rollout a couple of years ago, I thought this was the coolest thing and I didn't use it, so I forgot it. Tab key, when you're in an assembly, makes the parts go away so you can drill down to what you're working on. Now to bring it back, this is context sensitive, it depends on where your cursor's at. Shift tab brings it back. But if you don't know where they're at, Control Shift tab brings everything up, and you can just click on the part to bring it back. So modifiers, Shift, Alt, Control, Tab, all of these. The C key, for example, very simple, but it's got a lot of power to it. If you ever have your feature manager tree blow out like this when you're working on something, Shift C collapses it, Control C copies, Alt C switches between construction geometry, Control Shift C, copy appearance, goes on and on and on. How do I know this? If you go to Customize and you go to Keyboard, you can show any key that has, or any command that has a keyboard or a search shortcut. Pop to this top and you sort them, and you can see all the modifiers in there. Control, Alt, Control Next, Control Shift. Just print it. Do yourself a favor, print it out, look at it, and then get in and start modifying it. I will leave you with this. Anytime I am ready to leave a part, I go through a couple of quick steps. Hold down the control key, hit 7, it zooms at full screen, isometric. Hit B, that's a full rebuild, and hit S, that saves it. Just hold down Control, 7, B, S, you're ready to exit out of the part, which is what I'm going to do. I'm not going to save it. And we're going to jump back. Okay. Back to the top of the board. Totally tubular. This is a little bit manufacturing, a little bit of tips. This one's going, are you going to use a saw to cut that tube? This one's going out to Sean Casebolt at the Central New Jersey user group. Just going to take a quick look at making a tube. And for this one, I'm going to change it up a little bit. Last one I was using a lot of keyboard shortcuts. This time I'm going to use some gestures. If you're not using gestures, right click, drag your mouse, and when you swipe through it, it engages that command. So once you get used to it, it will start to go very quick and you won't see what's going on. So swipe over, I'm in a circle. Swipe up, I'm grabbing a dimension. And you can add your shortcut key to it. That's something that I do without thinking. If you hold down your control key and you drag your middle mouse, you can pan while you're in the middle of a command. I'm going to do a thin feature. I'm going to flip it, call it good. Now I'm going to do the cut. I'm just going to do a quick sketch of a line through here. Little reminder, a lot of people forget this. When you click and drag and release, it just draws a single line segment. Hit D to exit the sketch. If you have your mouse up in the top, rolling the mouse will run you through the tabs. So I'm just going to do a quick extruded surface, mid-plane, drag it out, right click, it's good. Cut with surface, grab that, right click, click on the surface, hide it. I really try to get people to pay attention to the cursor because there's so much that goes on there. So just watch your cursor. There's a lot of tools. This is what we'd expect. When you saw cut something, it cuts straight through it. Why do I bring all this up? What if you want to cut it with a laser? This one's going out to Travis and Brian down at the Slug in Louisville. If I want to turn this into a quick laser part, what I can do is just grab these faces. I'm going to delete the faces, hit the D key for OK. I'm going to thicken it. When it thickens normal to it. So this is how a laser cut. It cuts a tube. It just cuts through one side and then the tube rotates. So you're always going to get that flat edge there. You wouldn't cut something like this on a laser, that'd just be cut on a saw, but you would cut something like this on a laser because there's no way you could cut that on a saw. And if you're really smart, you can nest them together really nice. Something you can't do with a saw. That's a wrapped cut. How did I get the text to wrap around that cut? I used wrapped cut. This one's going out to our neighbor Jacob Huckins up with the Omaha user group. Let's take a look at wrapping this tube. Just going to do a slot and wrap it around this face. This is what it would look like if it was cut on a laser. All the edges are normal to the tube. And it looks really good. First thing somebody asked me about this, oh, could we cut a square tube? Okay. I'm just going to use my breadcrumbs to edit the sketch. Draw a square. I'm going to bring it in. I'm going to take this and turn it into construction, because that way I can still use the 2 to drive the size of the square without having to add any other dimensions. Throw some fillets on this. Say, yes, I know. Jump out of the sketch. Now I get an error because it lost the face, because I used a different face to create that. So all I got to do is modify my wrap, pick the face, and this is what it used to look like, because it just cuts that one face. They did something really great last year. You can now wrap it around a spline surface. So I can come down here, select tangency, let it wrap around, and now I've cut it. This kind of took away one of my favorite little tricks. I'm going to show you just because I still really like it. If you select that chain and do a fit spline, it'll wrap that into a single surface. You get the same message, but when you come back here, pick the surface, and it wraps it. Don't have to worry about doing it that way anymore, but I would like to show it because it's kind of cool. All right, now we're going to flex those pipes. And this one's going out to David Antanavigi from Long Island. I joke because I had to ask him how to say his name, and he said it doesn't really matter. So I'm just going to have fun with it. All right, when you have a tubing laser, people want to push it to its limits, and so you end up coming up with some really interesting stuff. This is something that I did on our tube laser. It's a tape cutter. You put the tape on here, it runs through the windshield and cuts on the grill. This is what it looks like coming off of the laser, because it was just a 1x3 steel tube. And then this is what it looks like folded up, because we can set it so we can fold it after it comes off the laser. How do we do that? Well, I drop in a cut, and then I use the flex tool to set the plane, set the angle, and bend it. I'm not going to go into this. There's a whole lot to it, but dig into the flex tool, bending, twisting, tapering, stretching, all kinds of fun. Like I said, I'm just throwing out ideas. I figure if you know that something's possible, it makes it that much easier. Bending a sheet metal tube. This one's going out to the Aberdeen Proving Grounds, Cameron Smith. This was a way that I kind of cheated the system. We had a tube that had notches, and what we were going to do is we'd cut it and bend it and then weld it, and the notches are basically just alignment. Well, how did I do it? I went to my sheet metal tools, and you'll notice that I left a little gap. This is how you usually make a sheet metal tube. Leave a little gap and it's fine. So I do a simple cut, mirror it over. I unfolded it so that I could add some reliefs. You can look in here and see the reliefs. I use the sheet metal tools to fold it back up, and then I call on my sketched bend, bring in that side, bring in that side. So it's still sheet metal part, but then I close the gap by doing a simple little extrude. So I get a cosmetic part. I can't flatten this anymore because I've completed the loop, but that's what configurations are for. You roll those back and you've got a flattenable part. All right. Let's go to that's exactly what I weld meant. You mean there's more? I actually saw this one on the forums the other day, and I was surprised that somebody didn't know this, but you know, people come into it at different times. So this is why I have this, you know, in case you forgot about something or didn't know it. This one's going out to Dan Riffle, excuse me, and Kathy Ross with the Colorado Swug. I'm just going to start a new part. And I'll do a weldment, sketch. I'm just going to draw a long line. Jump out of the sketch. I'm ready to add a structural member. Now, when you install SolidWorks, you'll get about a half a dozen profiles. Each of them has different configurations and sizes, but who wouldn't want to have this many choices? You do, you just have to go get them. So here's where you get them. Come over to your design library, SolidWorks content, pop down to Weldments. Any one of these, you just hover over it, control click, it downloads a zip file, and now all of a sudden you have all of those special weldments. What if you need a new profile? What if there's one that's not in there? Well, this one's for Tony Cantrell down in the Palmetto Swug in South Carolina. And I should probably visit him next time I visit my folks. All right, I went online and I found a nice profile that I want to use, but it was an AutoCAD file. I could just open up the DXF DWG. Here's that file. I'm going to make a weldment out of this. It's just a piece of crown molding. First thing I'm going to do is get rid of all the extra stuff. I'm really just after this right here. Now, I did kind of cheat and peek ahead and saw that they didn't do a very good job when they drew this, so I'm going to clean up some of the gap by decreasing the distance. That'll help close in where they weren't paying too close attention. All right, here's my profile. Now to set it up for my weldment, first thing I'm going to do, I select those two. When you select point, it'll give you the apparent intersection. I'm hoping everybody knows that. If you don't, you do now, you will use it. I'm going to turn this into a block, and the reason I put that intersection there is I'm going to use that as my insertion point. Block is done. Now just to throw everybody off, I'm going to delete it because I want to bring it in and put it at the origin. And then I'm going to spin it around so it looks good. Give this a horizontal relation. And just to really mess with everybody, I'm going to explode this block. And then I'm going to come in and fix everything. There's my sketch. I'm going to close out of it. That has all the information I need. My insertion point for the block, everything's defined. Click on the sketch. This is very important, and a lot of people don't realize this. Click on the sketch, save as, change your file type to a library feature part, drill down to your weldment profiles, and this is going to be a HC 1014. Save it. When I see the little L on my sketch, I know that it's set up correctly. Close out of that. This is my other part that I was working on. I can just go grab that one that I just made, Put it to that. And now I have some crown molding as a weldment profile. Now, let's expand on that. Carpenter, we have the trim. We're going to add it to something. This one's going out to Nicole Walden with the Chattanooga Squad Group. Nicole plays a major role with the user group leaders at SolidWorks World. She helps set up the get-together. She helps everybody line up hotels. She won the User Group Leader of the Year award a couple years ago. If you don't know her, make it a point to meet her. Okay. I've got a room. I took my floor plan and I put in crown molding. So now I can see how everything's going to look if I go over and open my drawing. Here's my room size, and here are my piece sizes. So I know what I need to cut. Not going to belabor it. I'm just showing you cool stuff that you should know about. This is probably one of my favorite ones tonight, and I can't take any claim for it. When you work in Weldments, you're generally working with 3D sketches. Last year, I found the best way to create a 3D sketch really quickly, and I owe all of that to Sal Lama. This one's going out to Kim Olson with the Kettle Moraine Swug, and this was just the coolest thing. I talk about it an awful lot. So, start a new part, and I'm not even going to worry about starting my weldment yet. I'm just going to start sketching, and let's do a weldment of the SolidWorks part model, and we'll do it in 3D just to, you know, make it really awesome. And I'm just really rough sketching right now. So I've got this. I'm going to make all of those equal. Put that in the midpoint. And I'm going to give this a dimension. So we have fully defined sketch. Going to extrude it, mid-plane. I'm going to build some intelligence into this and say equals this dimension right here. Still haven't done anything with a 3D sketch yet. That happens now. Turn on your edge filter, Windows select this, make sure you have all of your edges, do a convert entities, and now when you hide the body, you have a really nice 3D sketch of your part that can be easily changed just by hitting your body. This would take forever to draw if you did it the standard 3D sketch way, so I'm a huge fan of that. Try it out, really powerful. Okay, we're about halfway through. Don't forget to get in your statistics documents. There is a login that you can use to submit all of your stuff. We need to have everything in within the next 15 minutes. So if you have not submitted it yet, do so now.
We've got 40 groups so far, and I'm really slow at inputting them, so keep them up.
But that means we're doing well. So keep feeding them in. Dan said that we have about 40 groups logged so far. All right, we're going to keep going. We made that SolidWorks part. We might as well make a weldment out of it. This one's going out to Jeff Holiday with Marisug. We've got this. Let's just go ahead and say weldment. We're going to add structural member. I'm not going to use the crown molding. I'm just going to do some standard tubing. Right click, create a new group. There's a really good discussion on this on the forums the other day, people comparing processing time and rebuild time depending on how you build it. I like to do it like this, where they're all new groups within a single feature. To me, it just makes sense and it goes really quick. My Weldment's done. I've got one feature. I'm going to hide my sketch, come up to my cut list, and I'm going to update it. In this entire assembly, I have 3 different size pieces. And if I click on that original 3D piece, everything updates. I didn't think I would ever be able to model a weldment that quick. It's a really handy technique. All right, let's keep moving. Odds and ends. This is kind of oddball stuff that I think is interesting. Hopefully you will too. Using SolidWorks to tutor math. This is just giving somebody an idea of how something works, because we all know SolidWorks is math and geometry. This one's going out to our buddy John Matrician with the Western Mass SWUG, one of the Bacon Brotherhood guys. All right, let's start a new part. This one's really quick, and you'll be surprised how quick you could show somebody a complex math theory. I really like the midpoint line. We're not going to do Laplace transforms or anything like that. We're going to keep it simple. Today, we're going to talk about conic sections. Most people here should know about it, but if anybody's ever asked you, or if your kids start learning about it, this is a really good way to give them a good understanding, because this is all it is. Conic sections. We have a pair of cones here. A conic section is how a plane slices through a cone. So there's your circle. Angle it a little bit, bring her down, angle a little bit more. That's an ellipse. Bring it up a little bit. Whoops. There is a parabola. And if we pop over here, we can finish on a high note with a hyperbola. Now you understand conic sections. Sorry, I'm a math geek. All right, combine, not just for plowing fields, or combine. This one's going out to David Smith with Central Ohio SWUG. Now, if anybody's ever gotten something like this, let's go to design binder. And I've been cheating. I've been throwing a lot of stuff in the design binder just to show quick, pictures. It's a good place to store information. Check out the design binder. Somebody gives you a drawing like this. It has most of the information you need, but it's a fairly complex shape. Show you a really easy way to make it. Sketch pictures, if you haven't looked at it, look it up. You can put a JPEG or a bitmap into a sketch and use that as a picture. So what I did is I just took that, broke it into 2. I have my top view and I have my front view, lined them up, and now I can basically trace. So there's the top view. Then I dropped in the sides, and then I used the combine tool to only show where they intersect. So there's a trace, there's a trace. Hide these sketches. Pretty complex bit of geometry, and it was really easy. All right, multi-body makes it happen. That's how I did that. That was multiple bodies, and I used the combine tool to bring them all together. This one takes another look at it. This one's going out to Peggy France with the Northern Indiana SWUG. We're big fans of Peggy. We really like her. She's one of the first people we see on the way to World. All right. This was something that I did for a friend of mine. Once again, design binder. It's a pair of bar ends for a bicycle. Caps the ends where your grips are. It's a turned aluminum part, but he wanted this to be machined with a ball end mill. And there's a lot of different ways to show it. Here's what I chose. There's my revolve. I created this geometry. Right now it's a multi-body, so I'm going to go ahead and hide this. That's just a simple extrude. I come in with a fillet. It's really easy to fillet when you have something like that. I do a combine, spin it around. That's basically what the end mill would cut out. Roll it to the end. There's the finished product. Like I said, just throwing out quick ideas here, hoping to get the gears turning. It's a lot of stuff that I think people should know. You really think that will bend? This was something that when I was starting to learn about sheet metal, I heard from the press brake operators a lot. They don't hold back. They tell you how it is. This one's going out to our neighbors in Kearney, the SWUG scene, South Central Nebraska user group, Joe Urata. Now, the quickest way for me to learn was to model our tooling. So I have top, bottom, and I can drop the part in. Where this saves you is when you draw a part like this and you can see that it's about to hit the tooling. Right about here is where it crashes, and this is why the guy comes screaming at you. So you don't need to do something flexible like this. This was something really great that Gerald Davis from Colorado did. He was a user group leader. He put it on the forums. It's probably 6-7 years old, but it's still valuable. You don't need to make it flex like this. He did some custom stuff. All I had was the top and the bottom, and I could just mate my piece into it and see if it was going to crash. Save yourself some grief. Don't do like I did and learn the hard way. I'm sensing a pattern here. This one's going out to my partners in SLUGME Crime, Dan Hertzberg and Tom Cody with Band Swug. This is, woo! Woo! They are yelling. All right. Zoomed in on a bill of materials here. This shows a couple things I'm going to hit on a little bit later, but it's basically just, we need 4 of these, 76 of these. It's 2x4s. These are the lengths. What is it? It's a big room. When you build with 2x4s, you want 16 on center spacing. And if you want to do it really smart, you want it to update as you make changes. So how do you do that? As soon as I rebuild, I get the updated lengths and totals. Let's take a look at what I did. So here's my base part, and what I did is I just drilled a small hole to represent where the 2x4s will go. Did a pattern, and instead of doing spacing and instances like you normally do up to reference, and you specify a plane, and then you give your spacing. So 1 foot 4 inches is 16 on center. So my plane on this one is a little bit offset so that I could do this little trick here. You'll notice that I have a couple staggered here at the end. The reason I do that is because the drywall guys like it when you have a piece there in the corner so they can hang drywall right. So linear pattern, look into that, big time saver, and it looks really cool. All right, we're getting close. You got about 5 more minutes to get your results in. And I'm going to continue talking while you continue submitting your stuff. I never metadata I didn't like. I could go on for days about this. This is where we get into custom properties. That's what metadata is. I am a huge proponent because it's time savings. Do you really want to type all of that? Do you want to do it every time? This one's going out to our buddy Deepak with the Tri-City SWUG It is probably 6 o'clock in the morning, maybe 7 o'clock in the morning in India right now, and I'm glad they could join us. So we got to show them something cool, right? So I'm going to bring this back up, open up this part, and I'm going to start a new drawing, just a sheet metal drawing. And what I want to show is what we have right here, right now. Title block, fairly empty. I'm going to grab a copy of that just so that we have it for comparison. Come on. I've completely lost my mouse. All right. And I'm going to jump back into SolidWorks. Now I'm going to bring in that part. So here's my part. Watch what happens to the title block. This is how it should happen every time. I've barely scratched the surface of what you can do with custom properties. But just to show you what I did, here's the before, here's the after. Brought in the department, brought in the part description, brought in the part number, brought in the part weight. I brought in the project. I brought in the type of material. I brought in the material thickness. I brought in the surface finish. I know where the part is stored. Come down here, section area. We use this for calculating our nesting area. This is how much space it takes up on a sheet. This is total perimeter. This is what the laser will cut. We figure inches per second. That's how we figure that. Total surface area of the part. This is how we figure out how much powder we're going to use if we're going to powder coat the part. All of that came in just by dropping in the part with the metadata. I don't mean to sound preachy, but you should be doing this. I should be doing more with it. And I'm going to continue my rant. How do you keep tabs on your properties? SolidWorks makes it really easy to put this information in. This one is going to go out to Jerry Castle and Craig Riedel with NeoSwug. They have an awesome user group. I got to join them for their Hollow Solids meeting just a couple weeks ago via the web. They have a ton of fun. They're an awesome group. Okay, so I'm going to open up this part. This is my custom properties tab. These are the properties for this part. It's a purchase part. So I've got my description. This is what will appear in my bill of materials. Not worried about material. If I was, it would grab it from my part, or I could add it here. Finish. I can have my common finishes. Department. I touched on this earlier. If it's for the company, it'll show the customer. If it's for national, I can pick which project it's for. Vendor properties. Because this is a purchase part, I get it from one of these vendors. This is their number, and this is my cost. Now let's talk to Bob, the custom property tab builder, about how we did that, because that was the property tab, but let's see how I got to that point. And like I said, I'm not going to go all the way through this. I'm just going to show you a little bit. I highly encourage you to dig into this deeper. This one's going out to Jose Saldana with the Fresno Swug. So here's my custom properties. Here's where it came from. Property tab builder, I have it here because it's a shortcut. It's under your SolidWorks tools. So you go start SolidWorks, SolidWorks tools, property tab builder. This is what it looks like. On the left, these are all of your tools. This is where you build. You just drag them into this. And then this is where you customize. So to give you an idea, I'm just going to pull up what we're looking at over here. So I drag these over here. So like this here, department, I drag radio over. When I click on that, I get department. I can specify the number, define them, give a value. This is where I tell it what to show when I select that value. If I go down to vendor, it's just calling on a text file. There is so much you can do with it. This is just a drop in the bucket. dig in, play around with it. It will save you so much time. All right. Manipulating metadata. Now that we have all these custom properties in, we've got the custom property tab builder, we're throwing it in. What do we do with it? This one's going out to Will Radigan with the New Mexico swag. I'm a big fan of Will. I really like him. I went down to one of his meetings and had a ball. So here is a small assembly, and where custom properties really come in is like in a bill of materials. I have a couple different ones that I use. The standard one that goes on in drawings will be item number, quantity, part, description. But I have another one that includes vendor, vendor number, cost. And because I have cost and I have quantity, I can create another column for totals. So I can have these multiply out, and then I can do a total cost and have it sum it at the bottom. And then I can just jump in, take a look at this, see how much this subassembly would cost. Another cool thing you can do with this, assembly visualization. You can call on custom properties. Normally I'll do weight if I'm looking to reduce weight, or I'll do cost if I'm looking to reduce cost. For this one, just to give you a quick glimpse, red and blue. If it's blue, we make it. If it's red, we buy it. There's a ton of stuff you can do. Not even going to touch on half of it. All right, custom properties. At some point, you have to type in some of that. I typed in the number for the part. If I didn't have it in a pull down, I'd have to type it. There are ways to avoid that. We're going to do these for Tom Cody and Glenn LePage with the Central Mass swag. I'm not hearing any cheering, Dan.
Now, go. Go. Woo.
All right. Wow. My group makes noise. All right. If I start a new part, I have several different templates. One of the nice things that you can do, if it's a common shape or a common part, these are just a bunch of simple extrusions that have a family of shapes, T-shape, U-shape, L's. I put the sketch in there so that I can just start a new part. It's got the sketch, I extrude it, and it has configuration so I can change the size of it. Or if I have an 80-20 part, there's my sketch. I come into it, I hit extrude, go mid-plane. Now I have a fairly complex part really quick. I just didn't extrude. But the nice part is I didn't have to type anything because I put it in the template. So I have a description for the bill of material. The material's already been assigned. The finish has already been assigned. I could change it up if I wanted to put it on a certain machine, but my vendor information's already there. Everything's already in place, and I didn't have to type anything. So save yourself some time that way. All right, we've got about 10 minutes left, just enough time to draw me a bath. Funny story here, and I'm going to make it up on the fly. Jade had a rough day at work and called me and said, "Honey, can you draw me a bath?" She was not impressed when she got home and the bathtub was empty, but I had a really cool rendering. Rub-a-dub-dub, let's model a tub. This one's going out to Carl Gauger with the KC user group, also one of my favorite user groups. Well, they all are. We're going to start a part from scratch. And depending on the type of tub you want, you can do it with just a slot. Give it some dimensions. Everybody should know holding down the shift key to grab the outside of the circle. And we'll extrude it. That looks like a pretty comfy tub, right? Anyone? No. I would not want to sit in that tub. Let's add some draft to it. Okay, now it's just a cruel joke. Flip the draft. That looks good. The only problem here is we've blown outside of our area. So if you're pulling out a tub and you have 30 by 60, it's not going to fit unless you do some creative work with the wall. So what I'm going to do, a lot of people forget about this one. You can sketch on a plane and start your extrude elsewhere. So I'm just going to offset it and start at 18 inches up. I don't want my tub to float, so I'm going to flip my extrude direction. And now we're back to the goofy, so I'm going to flip that. That looks a little bit better. It fits in the space. We have the nice taper to it. I am going to put in a little bit of intelligence because right now we have it set to blind. I'm going to go up to the top plane, which would be the floor, for this, so that if I change this, it adjusts. Now, this is why I really push people to pay attention to their cursor. There's so much you can do with barely moving it. I'm going to click right here. There's my pop-up, select other. I'm going to click right here, get the bottom. Do you want to do a fillet? Yes, I do. Key in a value. Right click because it has the right click. And I've done all that with very little mouse movement. Same thing here, select the surface, hit shell, key in a value. If I drag this down just a little bit, I'm in right click mode. We've modeled a tub. What do? We got to fill it. So we're going to fill it for Peter Fisher with the Central Indiana user group. A really cool way to do this. If you remember me talking about all the little keyboard shortcuts, holding control copies, it works for planes as well. So this plane is going to be my water fill line, if you will. I'm going to use the intersect command to chop this with my plane. Right click, now it's got water in it. The one thing that I'm going to do is I'm going to uncheck merge results because what I want to do is have 3 bodies. So this right here is my water. Now I can take that water and find out how big my tub is. 15,000 cubic inches. This came to me in cubic inches. No, it didn't. If that doesn't make much sense to you, it's probably because we need to change the units. And I'm surprised there's a lot of people that don't realize you can set gallons as a unit. So now if we recalculate, 65 gallons, which brings up an important question. Is your water heater big enough? Well, let's find out. This one's going out to Jim Berry with the Northern Colorado SWUG. How do we find out? Well, we know it's 65 gallons. Let's say we have a 50-gallon water heater and we want this water to be blistering hot. Well, to tweak it, let's just add a sensor that will kind of keep tabs on this. So I'm going to set it for volume, do it for my water. Right now it's 54 imperial gallons. There's an SPR out right now. They're working on it. I set it for US gallons. Under the sensor, it's imperial gallons. It's fine. I'm going to say less than 42. That's the answer to life, the universe, and everything. All right, I'm going to expand sensors so I can see that total there. And I'm just going to drag this until my sensor goes off. There it is. So if I do a quick rebuild and I grab my water, go to mass properties, 52 gallons. I could fine tune it here, but that gets me in the ballpark. That's a really quick way to find out. Little tip, I use that technique for the weekly power user challenge on the forums, and I won. Not to brag, but I'm pretty proud of that. All right, tub's full of water. Let's make a drink, because you got to have a drink before you get in the tub. This one's going out to Jesse Vest with the Corpus Christi user group. I get to draw some really fun stuff. This should not comment on the crowd that I run with, but I was talking to somebody at a bar once and they said, hey, could you machine one of these drink measures for when they're mixing drinks? I would really like to have the 3-2, which is 3 ounces on one side, 2 ounces on the other. And what we were going to do is machine it so that there'd be a little ledge or a little lip, so when they fill it, they could easily see it. How did I do that? Same way I did the tub. I'm just going to roll this part back here. Started with an extrude. I created a volume, and what I did for this was I just made this shape, got it to an ounce, made this shape, got it to an ounce, made this shape, got it to an ounce, used combine to bring them all together, saved that part, inserted that part into the other part, did a combine to subtract it out. It's pretty easy. All right. Drain the tub, it's over. That's the last one. So this one's going out to the Minnesota SolidWorks user group. Mark Nelson up there. And how do we do something really cool like this? Let's find out. It's a lot easier than you'd think. So with this one, it's an assembly. The other one I did a part, but this one I have the tub is a part, the water is a part, and the rubber ducky is a part. It came from 3D Content Central. Thank you very much. The water is based on the tub. I just drew it as a big rectangle, used an offset surface, and cut it with that. So if I drag the water up and rebuild, it fills the tub. Drag the water down, rebuild. Did not mean to paste that there. Rebuild, fills the tub. So how do we make it drain? Let's go to motion study, move it out to about 5 seconds, drag the water down to where it's just about empty, calculate from start. And now we have a draining tub. We can save that out as an AVI file, which is what I did for the presentation. Got to end on a fun note. So, with that said, we did it.
Special thanks to everyone who made this possible. Todd for presenting, Tom for liaising, me for statisticking, Glenn for being the webmaster webinar monitor, and Craig for being the vocabulary challenge prize meister.